Hi everyone. Good morning, good afternoon. For those who are joining us actually from around the world, I see faces from outside Asia Pacific. Very welcome to this first session of UNESCO Jakarta Open Science webinars on open science from the UNESCO recommendation to reality in Asia and Pacific. We are very happy to have you here with us. I would like to just shortly share back the slides to review the housekeeping notes. We would appreciate if you rename yourself to show your full name and affiliation or your country if possible. Please keep your microphone muted when not speaking and use the chat box for questions and comments. Please raise your hand if you wish to take the floor after the speakers are done with their presentations. And please note that this session is recorded, and the recording will be shared. But in case you would like to share anything and you don't want it to be shared publicly after this session, please inform us. We can edit the video. Thank you for joining us again. So in this first session of the webinar, we have 5 distinguished speakers with us. The session is on open infrastructures for open science. Our panelists are Mr. Hendro Subagyo, Director of Repository, Multimedia, and Scientific Publishing from the National Institute of Research and Innovation, BRIN, Indonesia. We have Dr. Jelina, Tanya, Tetangco with us, who is a supervising science research specialist at the Advanced Science and Technology Institute under Department of Science and Technology of the Philippines. We also have Dr. Ahmed Husni Thamrin, who is Secretary General of School of Internet Asia, SOI-Asia from Keio University in Japan. We have Dr. Veerachai, Tanpipat, who is an expert in Hydroinformatics Institute in Thailand and is also chair of Open Science Collaborative and Resources, OSCAR, and also a member of working group in Open Science Working Group in Asia Pacific Advanced Network, APAN. We also have our colleague from UNESCO Beijing office, Dr. Sugiura, program specialist for natural sciences. I has been working in Jakarta office before I joined the office, and she was covering the whole Asia Pacific. At the time, our office was the Bureau of Science for Asia Pacific, so her experience from development of the recommendation is very useful for us in the discussions today. And coming to you from the people who have registered in this session, we have now online, I don't see the number, but you see that. We have participants from some 28 countries of Asia Pacific and a few other countries outside this region who have registered. I suppose not everyone is here, but we also know that we have participants from different groups, from researchers and academia, government and policymakers, university lecturers, librarian and data archive managers, students and school teachers. Very happy to have this diversity of participants with us again. We have also asked you about your level of knowledge and engagement about science. It's quite evenly distributed in the 4 categories. This time I noticed that we have more people who are practicing open science and less people who don't know much about that. So please also scan the QR code. We will ask you the same question again, which country you are from, because this will help us if later in this session we have a few questions for you, and we would like to capture the context of open science and open infrastructures in your country. So it would be very useful for us to know from which country you come, so later we can associate relevant questions and answers to the countries if it's a country context matter. So with this, I would like to invite you to scan the QRs and my colleague to share the slide so we see who is here from which countries. Nice. We have people from Australia. Oh, more people from Australia, Malaysia. Mexico, Philippines, Finland, Thailand, Indonesia, China, Malaysia is growing. Bangladesh, Afghanistan, Taiwan, South Korea, lovely. Japan, so we wait a few more seconds so more people have the chance to enter the name of the country. Nice to see also the distribution from countries is changing. I think in the last sessions, Indonesia was always the majority. Now Malaysia and Philippines are more active. Timor-Leste. And we have some 52 out of 90 people who have responded. Okay. I hope everyone at least has the curious now and you can scan it and enter your answers. With this, we can stop here. I will go back to my presentation, telling you a bit more about the context of this series of webinars as a part of a bigger project. My slides are back, right? Okay, so these webinars, this series of webinars are actually a part of a bigger project that we have designed here in UNESCO Jakarta to help implementing the UNESCO recommendation on open science. The project is capacity building on open science in Asia Pacific, aiming to advance collaborative research for sustainable development. And this project is funded by a JFIT fund from the people of Japan. The scope of project, as I mentioned, is for advancing collaborative science for sustainable development. When we talk about collaboration, we are talking about collaboration between various scientific disciplines, from scientists from different countries, and also scientists and other societal actors. So the project is aiming to do three different things. One is to address what is open science, building awareness, raising awareness on open science, what it is, especially in the context of Asia Pacific, who are the actors, why is it relevant to this region, and what are the potentials and requirements. Then the aim is to achieve this through this awareness raising webinars that you see are open to a broad group of stakeholders of science. In a later stage of the project, we are aiming to really go to how to technically practice open science, building capacity on technical aspects of open science, specifically targeting the researchers through some modules and online courses that will be also piloted into universities in the region. And then the third phase is to work with young scientists and early career researchers to actually put this in practice, to co-design collaborative research projects with different societal actors and implement the technical aspects of open science that they have learned, specifically in the area of disaster risk reduction. That is a very multidisciplinary, but also a very common area of research and priority for our region. Coming back to the UNESCO recommendation shortly, the recommendation is basically the first international setting instrument coming as a result of the request of UNESCO member states to provide a framework for international collaboration on open science, one of its main roles is actually to provide a comprehensive and inclusive definition of open science, going beyond open science outputs and opening the process of science, referring to different kind of activities and movements and practices that enable collaborative work among different stakeholders of science beyond the output, but throughout the process of science, enabling sharing, reusing, and reusing of scientific outputs in different languages. And it has four main pillars: open scientific knowledge, which includes publications, also open research data, open educational resources, open source, and open hardware. It includes open science infrastructure, which is both physical or virtual, and we will go more to that. It also includes open dialogue and engagement with societal actors, including through participatory practices such as crowdfunding, citizen science, participatory monitoring practices, and last but not least, opening dialogue with different knowledge systems beyond the conventional science system, which includes the indigenous knowledge systems and working and collaborating with marginalized group of scholars and scientists. So from this definition today, we are really focusing more on open infrastructures, trying to map some of the good initiatives in the region in different countries, but also at the regional level. Before going to that, I would like to give a very short overview of how open science infrastructures are actually defined by the UNESCO recommendation. So as I mentioned, these are shared research infrastructures. They can be physical or digital to support the practice of open science and serve different research communities. Examples of that would be major scientific equipments and laboratories, repositories for sharing publications, data, source codes, and also open access publishing platforms and journals, digital research services and virtual research environments, identifiers, persistent identifiers for different kind of scientific outputs, open computational and data analysis infrastructures, and also bibliometrics and research information systems. Some of the key characteristics of these open infrastructures as per the UNESCO recommendation is that they should be, as much as possible, interoperable and standards-based to enable collaboration between disciplines, between different countries, between different languages, and even different type of data, and enable access, reuse, portability of data. They should be, as much as possible, community-governed, community-led, and also non-profit and non-commercial, and they should be designed and supported for long time preservation and unrestricted public access. Also, recommendation has some provisions on how and in what kind of infrastructures countries should invest. It emphasizes that the investment should be systematic and long-term, both financial, but also building human resource capacity to provide these services and use the infrastructures. Reliable internet connectivity and bandwidth is one of the key and initial infrastructures that researchers need to do the research, but also to share the results and transfer it. National research and education networks is identified as one of the mechanisms for providing and aligning services, especially between different countries. High performance computing and cloud and data storages is another key area to investment. Federated and interoperable IT systems. So it's not like that everyone needs, or we need a big infrastructure that can serve everyone, but we can federate the existing ones in a way that we can exchange among them. And open source based digital infrastructure. So not only the access and use of these infrastructures are free, but also the base of especially for the digital ones, the base can be open source. So if another country, another institute would like to establish a similar infrastructure, they don't need to reinvent the wheel. Again, it emphasizes on community governed and non-commercial one, for example, to include principles such as fair and care principles when it comes to data, depending on the discipline and the community that is actually using this data. Integrated open licensing system for all the content that is included on these infrastructures is very important. The infrastructures should be collaborative and inclusive, either regional or multinational platforms for collaboration, citizen science, community-based monitoring system, and other platforms for participatory work. Platforms for co-creation between science and society are very important when it comes to research that should serve the society. And also enabling system and tools, especially with the new generation of open IT and AI tools, funding mechanisms to sustain these infrastructures in long term, especially when they are shared between different stakeholders or different countries, and community agreements on standards, metadata, and other aspects of what they share. If you want to know more in detail about how UNESCO recommendation addresses infrastructure under the UNESCO toolkit, one of the elements is the guide on open science infrastructures and how to advance them for institutes, universities, also at the national level. Please scan the QR code. There are many other elements of this toolkit that can be very useful for you depending on what's your engagement with open science. Okay, with this, I would like to now for all of us to hear from you. If you have used until now any open science infrastructure, now that we know what are open science infrastructures, there might be some infrastructures that you cannot fit in the options we have here. Please share them in the chat with us so it opens our eyes to what we might not have captured here. I will just go through the slides and I will the options, and I will ask my colleague to please share the Mentimeter for your slides. The options are if you have used open access repositories and research data platform, either at the national or regional or international level, if you have used open access publishing and peer review platforms, persistent identifier systems such as DOI or ORCID. Okay, I see the answers are already coming in. Citizen science and collaborative research platforms, high performance computing and national research networks, any of them, and also shared research facilities, laboratories, and equipments. And yes, so if you have other infrastructures that you have used, please share some information, or even if you have a link on that with us, it would be very useful for us to capture that and for everyone else too. It's very interesting that there is no answer that, okay, we have one person who hasn't used open science infrastructures yet. Okay, very nice. We have some 36 answers. Would be nice to know more about your experience with infrastructures. Okay, yeah, so basically, even if you're not a scientist, you can use open publishing platforms or open access repositories to read papers with many different type of publications, not only scientific publications. You use persistent identifiers, so it totally makes sense that we have more people using this. Sharing facilities and laboratories, shared ones, this is very interesting. And I think this is one of the areas that it's very costly for different institutes to establish their own equipments and facilities. But it's very nice to see that some of you are using shared open facilities. And of course, high performance computing is not something that every individual institute can afford. So it's very nice to have them either at the national level or for different disciplines. Very nice. So please feel free to continue answering. You can pick multiple answers here. And while you contribute to that, I would like to invite our first speaker, Mr. Hendro, to please tell us about the context of Indonesia. You have been actually the focal point for Indonesia to report on the implementation of the recommendation after 4 years of its adaptation. So it would be
Yes.
very interesting to know about the broad scope of infrastructures in Indonesia. And I know that Indonesia has actually one very good initiatives about physical open science infrastructures. So it would be very good to hear more about that. And please let us know if you have faced some challenges in developing and maintaining these infrastructures and how you have addressed them. The floor is yours.
Thank you, Veerachai. Good morning, everyone. Let me share my slide first. Do you see my slide? No? I don't.
Yes, it's coming.
Sorry. Do you see? No, sorry. Okay. Now you see my slide?
Yes.
Okay, thank you. So thank you, Veerachai, for the opportunity to introduce our open science infrastructure. My presentation will be in 3 parts. First is about BRIN, and then open infrastructure for research in BRIN, especially laboratory and facilities. And then the closing, I will tell you about the challenges and notes, what we have to do in this project. Okay, first, why was BRIN born? This BRIN is, before BRIN, we have 5 research institutions. Like me, I came from LIPI, Indonesian Science Institution, and then in 2021, we integrate, fuse to one organization, we call it BRIN. And the reason why BRIN is born, because we want to integrate, and we want to consolidate our research. And the most important thing when BRIN born is we will open platform. The 3 things that we will open is human resource, infrastructure, and network. So with this open platform, we can collaborate with global academics, and we will give collaborator with the free of charge to use our open platform, not only infrastructure, but also human resource and network. And also we will collaborate with business player, also free for charge for partner, when we research, doing research collaboration. And for service the open research infrastructure, we develop what we call a platform with name ELSA. In Indonesia is Layanan Science, Science Services Electronic. And this ELSA at BRIN is a sample how we provide our open platform. And in this ELSA, we want to integrate lab services from 5 institutions. We have thousands laboratory and equipments, and we want to integrate and standardization the business process to service the laboratory. And also we develop ELSA as online tracking and also the payment tools. So we can integrate the payment with the government mechanism. And we introduced not only one-stop station web-based system, but also we develop new initiative we call ELSA Point. This is virtual money. Yeah, not we cannot transfer it to become rupiahs or dollar. No, but every researcher in BRIN will initially will given by about 20 million 20 million ELSA point. So when researcher will use the laboratory or equipments or testing in the laboratory, we will charge the researcher by ELSA point. But when the researcher is not our collaborator or the industry is not our collaborator, they will pay by rupiahs or the real money. And this ELSA integrate all our laboratory from across Indonesia. First, when we BRIN born, we have 80 locations across Indonesia, and then we integrate all. Now only few. The big one is Cipinang, Serpong, Jakarta, Jogja, and also Bali and Surabaya. Yeah, about 6 until 8 location only. And the library and research facility that we will open is across all the science topics. There is from biodiversity, biological collections like biosafety level 3 and 2, also in nuclear research lab and many things. Yeah. And for example, we will introduce to you HPC, high performance computing laboratory. This is the statistic. Now in this year, we have about 143 laboratory and sub-laboratory, 723 equipment and machine, and also on. We have also 23 HPC services, yeah, in ELSA. And when we look to transaction in user satisfaction in the first graph in the middle, we can know that the transaction is increasing every year, increasing. And also the user satisfaction also increasing, but because the maximum index of user satisfaction is 5 from Indonesian government, so maybe I don't know, maybe this maybe just not increase, yeah. We will stop in 4 point extra. And when we look to impacts the points, we like ELSA point that I will introduce you before. In the, we can see that the impact is increasing. So the utilization of ELSA point is increasing, and if we see at 2025 decrease because there is some political decision in our government, there is efficiency from budget, so there is decrease, and research activity also decrease, so the ELSA point is decreased. But if we see the external user, sorry, not from BRIN, yeah, outside BRIN, by professions, the most large profession is administration. Yeah? I don't know why, but the second and the third student, and the third is technicians. But if we look by institutions, we see that the government, private sector, yeah, private institution, the bigger user. And in 2025, last year, there is the private institution coverage about 57%. So we look to open SPG laboratory infrastructure. We have a project developed for ASEAN, this decision from ASEAN, and we collaborate with South Korean government via KISTI. We developed the ASEAN SPG, and we hope in the early 2026, maybe April or March, I don't know, we finish this infrastructure. This ASEAN SPC using ID RAN to connect to outside network, and we have computing nodes about 3 petaflops and storage about 3 petabytes. And also we have interconnects between server about 400 gigabit per second. And this project is a flagship from the Korea ASEAN Digital Innovation Flagship or KADIF, and its aim to create a shared high-capacity computing environment to accelerate AI development, AI research, big data analysis, and scientific research across Southeast Asia. And we start the ASEAN SPC school from last year, if we are not wrong. And this user is very happy and hope this ASEAN SPG will be used maximum in this year. And we look the mechanism of the ASEAN SPG project. Almost our deputy collaborate with these projects, and especially from deputy infrastructure, research and innovation, deputy RI, this deputy that provide the infrastructure of ASEAN SPG at Cibinong and at Serpong. And we will compute large language model, AI for high resolution satellites imagery, AI for autonomous system, AI in scientific computing, and also fundamental of HPG AI. And the output, we hope we have ASEAN.ai that is will be used by our collaborator from AI. And also we have collaboration with Korea. We have project BRIN. This project is to develop more better research infrastructure, especially management. And its project start from 2023, focus on 4 projects: integrated procurement alignment, enhanced equipment visibility and access, systematic maintenance management, and also interoperable data ecosystem. This ongoing project, and I don't know if I believe that the project will be last in 2025, last year, but maybe this project is continue. I don't know. We still wait the progress. Last, we have challenge and future tasks for open science implementation. We need superstructure. There is human resource institution aspect, individual, society, institution, agency, and communities. There is a lack of awareness and a lack of capabilities. And also, we have the culture of cross-agency collaborations remain weak. There is big silos in our agency across Indonesia, and strong sectoral egos. There is difficult to tackle, but we still trying. The third, the research, education, and literacy ecosystem still needs to be improved. Yeah, we big country and very big nation and very big problem. So literacy is still our problem. And the last, national data or information sovereignty in the era of openness is still difficult to tackle. How to adjust our sovereignty and also openness. This big problem from us. The second challenge is infrastructure. We want to increase the openness and integration of government and non-government research infrastructure, but it's still a big problem. Although in the government, we starting to integrate our services, especially with the Kemendikti-Saintek, Ministry of Higher Education, Science and Technology. We since December 2025 last year, we initiated the integration project for open laboratory services. And as a pilot project, we began with infrastructure from our laboratory from BRIN and also selected university, the big university like University of Indonesia, University of Gajah Mada, ITB, and so on. And last note from me, we believe that Indonesia support the UNESCO recommendation on open science, and we began promoting and implementing through regulation, policies, and guidelines within ministry and research institution, university, and communities. But there is a big homework, not finished, and we still struggle with this thing. The second, we believe that Indonesia has begun to implement open scientific knowledge, open infrastructure, and citizen science, but further strengthening and support for protection of indigenous knowledge is needed. There's some difficult problem if the open like citizen science implementation, we use this in the indigenous knowledge era. There's some difficulties, how to protect but also to open. And last, furthermore, we want implementing open science still requires strengthening regulations, policy, and business processes, as well as the development of more systematic mechanism across level and sector. Maybe this, last for me. Thank you very much.
Thank you so much, Pak Hendro, for this comprehensive overview. It's very interesting to see that you are doing this in such a vast country in Indonesia. I believe if one can provide open infrastructures across Indonesia, this could be a very good example for countries when they want to work together, because the geographical landscape of Indonesia is very vast and very diverse, and I really understand what you mean by all these challenges. Thank you for sharing also on the ASEAN HPC. We have one question in the chat who wants to clarify for which countries this infrastructure will be accessible. I understand this is the first ASEAN infrastructure for open science that is developing, right?
Yeah.
So is this open for all the ASEAN countries, or is it going beyond ASEAN?
Yeah, first we will open to all ASEAN country, university and research institution, but we believe that we will open also for beyond ASEAN. Yeah.
Nice. Thank you so much. We have one more question for you in the chat. Please feel free to answer in writing. We will go to the next presentation to make sure that there is enough time, but also at the very end of the session, we will have a Q&A session. Okay. So with this, I would like to invite thank you so much, Pak Hendro. Again, I would like now to invite our second invited speaker, Dr. Jelina Tetangco from Philippines, DOST-ASTI, to please tell us from the Philippines side, what are the key infrastructures developed in the last few years? And also, please let us know if the Philippines is engaged in any South-South, North-South, or international collaboration to expand or contribute to open science infrastructures. The floor is yours. Thanks.
Okay, so good morning, everyone. My name is Jelina Tetangco. I am from the Advanced Science and Technology Institute. It's a research and development institute under the Ministry of Science and Technology. So let's flash my presentation. Okay, I hope everyone can see the presentation slide. Okay, so this morning I'll be happy to present our contribution to the discussion on the crucial role of science infrastructures in open science, the perspective of the Philippines, and focusing our work in my organization. Okay, so this is my very short outline for the presentation. So I'll be going through an overview of the science infrastructures that we have that facilitate open science. And of course, with this, from the national perspective, I would also like to emphasize the importance of regional cooperation in. So I've mentioned about my agency. Now, let me just go straight to science infrastructures that we have. The main infrastructures that we have is a national research and education network, which we have been operating for the past, more than 20 years. So it's connecting universities such as the University of the Philippines and its campuses, and other research organizations like the International Rice Research Institute. And we're also connecting some government organizations, especially those that have a research mandate in their tasks. Now, Preginet is also connected to global RENs. So we're connected through the Asia Pacific Advanced Network to the European network through the Trans-Eurasia Information Network. So that is the NREN. And then over that, we also operate the a computing infrastructure, which we call the Computing and Archiving Research Environment. So with CORE, we have been operating this for more than 10 years, and it provides three primary services. So HPC, Science Cloud, and data archiving. So we provide these resources for free to the academic and research community in the Philippines. Okay. So these are the science infrastructures, but what value do these science infrastructures have? So of course, we support research and communities of practice, and some of these examples are in this slide. So we support the telemedicine community of practice. This was actually started in the Asia Pacific Advanced Network, which we attend yearly, twice a year. This is one of the more active communities or groups APAN. And through this, we have facilitated the creation of the telemedicine group or telemedicine work in this practice continues to be very active in APAN. And then we also provide a lot of computing resources to various initiatives. During the pandemic, we provided a lot of compute resources for our researchers that are focused on COVID-19. In rice genomics, we also, aside from the computing resources, we also host the 3,000 Rice Genome Project of the International Rice Research Institute. And in other fields that we support is on disaster management. We are supporting the Weather Bureau as well as the Seismology Agency in their applications on disaster management. Like mapping of agriculture and fisheries resources that the National Census Agency is initiating. So these are just some using. So this is just to provide a snapshot of the infrastructure that we have. It's fairly modern. It's small scale, but we are in the next in the next few months, we expect to grow this network. Especially, we are also expected to support some of the AI projects of the Ministry of Science and Technology. So we will be growing this in the next few months and in the next 1 to 2 years. So on the right side are just some of the academic institutions and government and research institutions we support. Okay, so this is just a snapshot of the users of our general purpose HPC, as well as some of the users of our GPUs, or those are focused on AI initiatives. As you can see, we have 70% of them, or 80% of them, are in the academe. We also support some government and then some research organizations. Sorry. Okay. So that is one of the values that we have. The next one is we also host research data. So this is on another pie of the open science. I will not really go deep into this since this is for analysis, but over this infrastructure, we also host the core data catalog. So ASTI is also generating a lot of data. So we came up developing a data catalog where we can host all these research data and make them publicly accessible. And of course, with this platform, we also hope to promote more collaboration, not just locally, but also regionally, internationally. So we have about 44% of the core users coming from the academe, particularly from the University of the Philippines, which is the biggest university in the country. So these are just some examples of the data sets that we host. So as I've mentioned, we host the International Rice Research Institute's 3,000 rice genome projects. We have a couple of storm surge and landslide hazard maps, and some drought situation maps. So at present, we have around 14 data sets coming from 9 organizations, and we hope to grow these data sets even more in the coming years. Okay, so our next step for the data catalog is we want to be able to have users publish their own data set. So that is something that's in our pipeline. Okay, I will not go into this, but this is just a snapshot of those who download our data. So it's coming from government and private sector, but a lot are still being downloaded from the academic community. And on the right side are the field of interest of the users that download these data. Okay, so in summary, science infrastructures enable open science by supporting research, local, regional, and global research, and by hosting research data through our various collaborations. And now, I think this is my last slide, but what is the importance of regional cooperation in the context of what we do nationally? Well, of course, I think our previous, our gentleman from BRIN mentioned about the ASEAN HPC. We participate in that, so we do get shared infrastructure and resources, including policies, of course, on regional level. We participate also in that in the ASEAN HPC. We also have one ASEAN regional research infrastructure that is also related to the ASEAN HPC. So the second is in terms of capacity building and knowledge exchange. So we cooperate with SOI-Asia. Dr. Husni is here to present about it, and also Arena Pack. So we also participate in that. And lastly, of course, in terms of the best practices in BRIN and HPC operations and platforms, addressing common challenges such as disaster mitigation, and we all get this from our participation in communities such as the Asia Pacific Advanced Network. Okay, so I guess that is the 10 minutes that that I have, I'll be glad to answer any question. Thank you.
Thank you so much. Very interesting, very diverse. We cannot have every country in this short time that we have, but we have captured a lot of these very interesting infrastructures and initiatives in different countries of our region. And based on the diversity, we have picked a few of the speakers for this time. It was very interesting, Dr. Jelina, to see in your the different infrastructures that you provide, how locally relevant research is enabled through your infrastructures, health, agriculture, disaster risk reduction. We don't see this focus on local issues in, like in some of the other fields, and when it doesn't come to open science infrastructure. It was also very interesting to see for me from both presentations at the national level that by monitoring the use of these infrastructures, actually, we can capture the diversity of stakeholders who are engaged and are using, and they are engaged in different science fields in your country beyond the science community itself. Thank you so much. You closed by the importance of regional collaboration. So I would like to go to our next speaker, Dr. Husni, and invite him please to tell us firstly about the importance of good internet connectivity and bandwidth for research, and telling us how internet that we need for research is different from the internet that we use on daily basis, and why we need to go beyond the national level, and what kind of regional collaboration enables providing such internet. And please tell us what's the role of SOI-Asia in this. Thanks.
Yes, thank you very much, Festa. I think the presentation by Jelina was a very good segue to this. And yeah, just to introduce myself, my name is Achmad Husni Thamrin, usually called Husni. I'm working for SOI-Asia now as the Secretary General. So let me share my screen and see. Hope this works. This would work, right? Okay. All right. So I hope you can see the screen. What I'm going to talk about today is the research and education network in Asia Pacific. First of all, I'm from SOI-Asia. We have partners in all these red dots. The westmost is Nepal, and the eastmost in the Asia is well down there in the Timor-Leste, and we have partners in Australia as well. And I'm based in Tokyo. We started with satellite networks back in 1996. So you can imagine at that time, the connectivity was around the world was very much different from what we have now. And then with the technology changes and the speed becoming more and more, we're working with fiber. Before we go into that, this is how we do our work. We have layers from research, education, and digital platform for micro-credential. And also we have an effort in the research data platform, mainly in the digital humanities. And we have research network testbed, both in the satellite as well as in the infrastructure using submarine cables working with ArenaPac. So this is what we are. And then, since I mentioned ArenaPac, this is ArenaPac. It's a collection of submarine cables. This is operated by White Project with APAN. We started this in 2020. As you see, this part of the cable, these are operation as Jelina mentioned as well earlier about Arena Park. You see there's a link connecting ASTI in Quezon City, Manila, to Guam. And in my place in Tokyo, we're connected to Guam as well. And then we connect to Singapore and Penang, and also in Malang in Indonesia. So these are very high speed, 100 gigabps connectivity among between this region. And we have an Arena Pack has planned to connect to others, the one that you see in the Pacific area, many dots there. So we expect to see this coming up in the future. So what you see here with the evolution from satellite network now going into very high speed with the submarine cables, we can see potential collaborations in the region. And not only in the Asia Pacific, you see here, this is a collection of research and education networks in Asia Pacific. You can see everything from even in Afghanistan, Pakistan, India, Sri Lanka, Nepal, Bhutan, and then down to Australia and New Zealand, and also Timor-Leste. And not only here, but what you see on the top left to Jian. Jian is sitting in the Europe and UK, and also to Internet 2 sitting in the US. So you can see the connectivities not only in the region, in the Asia Pacific region, but beyond that, going to Europe and US, and from there go to Africa and Latin America. So you can see this network is for research and education, and it is different from our usual internet. And I will talk about it later. And this is a list of RAN community in the region. What you see here, just a list from by alphabetical order. I hope we capture everything here, and let me know if I miss anything here. Now, I've been talking about research and education network like this, okay? But maybe some of you are not familiar with the research and education network, and you might ask, what is this, and how does it differ from the internet that we use? Like we using Zoom today, we use the internet, but what is this research and education network? So in terms of technology, internet and research and education network, it's practically the same. The difference is that a research and education network, or we call it RAN, connect research and education organizations only. And typically, RANs do not carry commodity traffic, means that you cannot use YouTube, you cannot use Google, what have you, the one that we use, okay, on daily basis, and typically supported by the government. Okay, so these two things typically means that there are some exceptions where the research education networks also provide connectivity to Google and all the hyperscalers. Okay. Also, there are RANs that are not supported by the government, but it's a private enterprise and also community enterprise there. And then what's different here is, rather than thinking about the relationship between RANs as a customer-provider relationship, okay, RANs use coordination. Okay, so that's how RANs are different from the internet. Okay, so hopefully this is quite clear for everyone. So that's why if you're sitting in the research and education organization, hopefully you have access to both internet and RAN. Okay, and we will see how these two differs now. All right. So let's think about it this way. So this is daily internet traffic. If you're using the internet, I believe everyone's using the internet. If you're at home, if you see the red lines here, this is pretty different pattern from the office. So at home, usually the traffic is up in the evening till midnight, and when everyone sleeps, it goes down, and everyone wakes up, it goes up again, the bandwidth usage, and then at time of the day, in the daytime, it's no one at home, it's practically no traffic. But at that time, people are in the office or in the school, the traffic in the university or in the office increase during 9 to 6, right? And after that, everyone go back home, and then no traffic. So this is daily, on daily basis. On the Research and Education Network, and RAN, it's a very different pattern. So this is just an example that you can think about. Instead of a daily, this is monthly. You see the time on the horizontal axis. This is date from 1 to 30. And then what you see here in the typical RAN, it's practically low usage. Like this, you see here, low usage until someone uses it, peak like this, and some peak can last days. Okay, so these peaks happen when there are experiments or collaborations with large data transfer, and this can last days, right? So this is how you think about Research and Education Network, and it's pretty different from your internet, right? So what happened here is like this. This is actual from measurement page. So you can see this is from March to July. You can see the date here, okay, from one point A to another point Z. So this is one circuit. So you can see the average is like this in terms of hundreds of megabps, and then the maximums in the gigabps scale, and the peaks can be beyond 15 gigabps, right? So that's why in the Research and Education Network and RAN, we need to have a very high bandwidth to support research collaborations. Okay, so again, the point of RANs, okay, the value proposition of having RANs is to provide large capacity and coordination. So if you see from the example of the bandwidth usage, you can see this, the one in the dark gray, like this, in the grayish color here. This is sort of a low volume traffic, but sometimes people are doing experiments with high traffic and the low long range, meaning taking days. At that time, the coordination is that you can prioritize this experiment traffics, okay, and make the background traffic less priority. So this can happen in the Research and Education Network, and this cannot happen on the internet, okay, because of the relationship is customer provider, not coordination. Okay, so this is one example in terms of priority. And another example here, this is actual what's called APAN, this coordination in the Asia Pacific Oceania between the circuit owners. We have ARNet in the Australia, Rians in the New Zealand, and the Singaran and Pacific Wave and Kisti, what have you here. So let's just think about this. If you see this, there's a link from Guam to Hawaii, okay, owned by the University of Hawaii. Okay, suppose the traffic goes like this from Manila to Guam and to Hawaii, all right? And if this link is disconnected, all right, the RAN community can coordinate. Say, okay, from Manila, we want to traffic to Hawaii. Let's reroute from Manila to Guam, Guam to Sydney, Sydney to Auckland, Auckland to Hawaii. It's a long way to go, but that is possible because this is coordination, not customer provider relationship. So that's why the research and education is something important. And if you're sitting in your organization and your organization is not connected to research and education network, I believe it's a good way to think about this, to advocate in your organization on how to connect to research and education network like this. Because at the end of the day, RANs serve as a crucial infrastructure to advance science collaborations. I think that's a brief introduction from me. Thank you very much.
Thank you so much, Dr. Husni. Very interesting. I think internet, I think I'm privileged to have well connectivity on a daily basis. So we just take it so for granted. We don't have an image of all the infrastructure in the background unless we lose our connection. So thank you so much. With this, I would like to just go, and you gave actually an introduction and a good trailer to our next presentation from Dr. Veerachai from Thailand and APAN. So I would like you to please tell us more about RANs, especially at the regional level in Asia Pacific, and also how you see that regional coordination mechanisms such as APAN can support interoperability, federation, and alignment between RANs, and all these criteria mentioned by UNESCO recommendation, community-led. I think these are things that can be managed much better at the regional level. So the floor is yours to tell us more about this.
Okay, thank you. Thank you very much. Good morning, everybody. Thank you, Husni. That the ending is like literally connected to what I'm going to say. And then my name is Veerachai Tanpipat. I'm from Thailand, from Hydro Informatics Institute, under the Ministry of Higher Education, Science, Research, and Innovation. Getting very long now. And then I also acting as chair of the working group in the APAN, Asia Pacific Advanced Network. And I will tell you a bit more about APAN and the working group that we are trying to do. Let me share my slide. What's this one? Oops. Okay. So my slide will be my talk will be in overall about the what is APAN and the connectivity. That's when the Husni gave the example, if something happened to like the cable, submarine cable get cut, and we can reroute it. So APAN is a place for those people to come and see each other and then talk face to face. So it can be handled very quickly because we know each other, and we face to face is one thing that we need to have in terms of the meeting. Online we try during COVID, very difficult to get things done. And then the first time we have face to face meeting, then the thing that we are waiting just easy to handle. And I'll give the example of the working group that we are working. The first one is the agriculture within the APAN, and then the disaster mitigation that shared by Philippines, DOST, and the open science collaborative and resource. We just rename it because I'll tell you a bit later, and some challenges that we face, and of course the final words. So Asia Pacific Advanced Network started in 1995, a little bit before SOI, but I think because of this, that's why SOI is a part of the APAN since then. So we work together and we based on different country REN. So they have each country, usually they have national REN, And you saw the list that Dr. Husni already presented. So in each country they have that, and they send a representative to attend APAN, and we can meet in the different working groups. It really depends on their interest. Most of the NREN, let's say all the NREN connected with the high-speed network, but the speeds are different. So that's one thing that when Arena Packs provide the 100 gig, that's help a lot. And this we connected around like 20 economies spanning from Pakistan to the next host, New Zealand, in the our next meeting. Then we try to partner and then have the MOU with different, like maybe company or some organization to work together. So usually we have 2 times of the meeting within the a year. Then we around 200-300, sometimes 400 attendees. It really depends. The number we would go up if the host country, like last time in Bangladesh, they pay for registration fee more, so the local host can come. For the open science session that we have, a lot of local from libraries, because we request that to the local host to pay for it for them to come. And we have the internet. We try to build on the working group to have the applications. The most famous one, I believe, is the telemedicine. Now they are very, very good. So they need a very stable internet to do the virtual surgery. And now is when a participant around 1,000 or 1,000 something each time that we have APAN. And they do it like Monday to Friday. We already closed, everybody going home, but they still have session. Like, oh, why? So it's depend on the time difference, the time zone. So APAN, based on that, the working group, so we should try to share the data. Some we conduct the workshop or the training, and APNIX always have the training session for us all the time. And we try to have more application. They really depend on the movement that this network connected and try to use. This is the update last 2 years ago, but now maybe a little bit different. But this is on the web page, so I use this one. So this is the picture of how we connect within APAN community. Okay. And the APAN usually drive with the working group of the international collaboration in the technology discipline domains. So for example, I will give you example here regarding the agriculture, the DOST disaster, and open science, which we used to use the name open and sharing data, because at the beginning, I think in Dalian, I don't know which year, maybe almost 10 years ago, we have a concern about, a researcher concerned about how to get good data. So we like, I don't know. But then we talk, then okay, maybe we try to use APAN as a platform. And later, the one that really support us is the NII, the National Informatics Institute of Japan, who SciNet is under there. So we work closely with that. And then UNESCO work with ICE for with the disaster before. So, and then now you guys are doing this open science. So we get engaging and have a session together, discussion, and try to push this thing forward and within APAN as well. But it's not easy. If we out at the challenges at the end, I'll tell you why. That's my opinion. So now we adding the AI, the HPC working group that they have IPv6, but it will change. We'll add some, if no activity like disaster mitigation. We used to have Earth monitoring group that's the host by NOAA, but they didn't come for a long time. Then we changed it. Taiwan, as an SGC, as Academic Sinica, they decided to have this disaster mitigation when we had APAN in Indonesia, I think in Bandung. Then we had that since, and we work together. We try to connect different working group together. So agriculture at the beginning, we try to find the application to use the technology on top of that. And at the beginning, University of Tokyo, Professor Ninomiya is the one who started, and we still keep going until now. We aim to accelerate the state of the art, because we realize that it's so many people, the climate change. So you really need technology, if we could provide and get together to make sure that in the future we could sustain or have the, let's say, the balance of the food supply and demand, which is not easy. I can tell you this, not easy. But we are trying to support in a way that we could. For example, Sri Lanka last year, they founded this agricultural working group within the country, so they can work closely with APAN to improve the agriculture technology that they are using within their country in Sri Lanka. So that's a good beginning, and I'm very happy to see that. Disaster mitigation next. Now we have been using the case study and talking a lot, but last a few months ago, I don't remember the month, there was a cyclone or something going through Malaysia, and then hit North Sumatra badly and went to Sri Lanka. So I had a brief meeting with the chair and co-chair. What is his name? France De Leon, yeah, France De Leon from Philippines, and the Eric Yen from Taiwan. Then we try to change it, not doing just case study. We want to give good example, and then we do it. We did it for Philippines to give example to other and try to improve it from there.
Sorry, Dr. Veerachai, we need to get
Yeah. Okay, I'm sorry.
we have one more presentation, and if you
Right.
want some time for this.
Okay. So this open and sharing data changing to open science collaborative resources. The aim is just try to promote it and do the practice within APAN. And then the open and sharing are difficult, as it's not easy like we are trying to. So the main thing that we have been talking is the cultural change. We try to get people to have this, but it's not simple. Like, we can have the meeting like this. So let's go because of the time. But the challenges is the data information accessibility. You can talk about it, but when you try to access it, it's not that simple, like you said. We tested before, we try to access some like NCI data, Sentinel data, but when we want to process those data, it's Australian tax, so other country cannot utilize it. That's also the problem. We tried for almost 2 years, not working yet, but maybe with the FUSA now they have the similar data center that we can use. Good quality of the data, difficult. Yes, you can open a lot of data, but how do you know which good quality of data can you access? The common goal and work together with the same direction. Okay, not enough resources and workforces to push it. Move beyond talk and discussion. Like now we have talk, discussion, and then bye. See you next meeting. Have seen a lot, but maybe it's a time to move forward, doing something. So I honor the agreement and commitment. People are like, yes, always say yes, see you next time, and yes again. And for a few years, like, yes, 2 years ago, is it okay now? That's always happened. So cultural change is the fundamental component for the collective progress. Then sustainability that very difficult because people change, everything change. Yeah, so that's the challenges. So last slide, I always use this one. It's a climate change. It's not climate change, it's climate crisis. Disaster and severe event is inevitable. It will come. You can run from it, cannot. So building resilience and sustainability among us is our ultimate goal for dealing with the future climate uncertainty and extreme events. So we are in this different boat, yeah, different country, but we are in the same storm. So, all hands on deck, helping each other, thinking globally, act locally. So imagine what can we accomplish when we work together, and then like ASEAN motto before, stronger together, one for all and all for one. Thank you very much.
Thank you so much. I hope open science will connect our boats together to stay stronger. And I agree with you. We need a cultural change. I hope this contributes to that, but we need to go beyond that. Thanks for opening our eyes to some of the challenges. We do have actually a question on the challenges that our audiences are facing. So I would like to invite my colleague to share another Mentimeter slide for our audiences to mention what are the main barriers in using open infrastructures they face in their context. Please scan the curious. It's the same one. So basically, if you open it again on your phone, you will be on this slide. Please share your inputs with us. If you face any challenges, if there are existing open science infrastructure in your country and field, and you cannot use them, there is access policies, lack of awareness of it. Exactly, this is basically one of the main reasons for having this discussion at the regional level, to shine light on what exists, especially for those who need them or for those who are developing or would like to develop it, to really hopefully create some potential collaborations between those who have done this already and those who are having a vision on developing that. Funding, commitment, accessibility, information, missing of data. This is a bit not clear for me, but if you can also add a bit more on that. Vision and funding, plans and policies again, lack of awareness, integrating different standards and business processes. This is a big challenge, because even if at the national level or on every infrastructure, we have a working system, aligning them together and integrating differences between them is a big challenge. Networking, information, internet connectivity. Just because we are a bit short with time, please keep sharing if you have more challenges in the chat, and we collect them from the chat. We have one more question for you before I invite my colleague. As it was discussed, there are some challenges also that can be addressed at the regional level. So if Kasumi-san, if we can go to the next question to also get some inputs from our audience on what they think should we do collectively, either in UNESCO, APAN, or generally at the regional level. What should we collectively prioritize at the regional level to strengthen open science infrastructures and increase their use? Collaboration instead of competition. And that needs a lot of incentives and a lot of change of culture. Common understanding, having dialogues for sure, creating common vision, dream and action. And I think the HPC ASEAN is a good example of creating this common vision and aligning interests to really shape something that everyone can benefit from. Dream and action, that's nice. I like it. I know open science a lot of times sounds dreamy, but I think we need to dream high to reach somewhere. Engagement with policymaking and enhancing awareness for the users, promote directly at each NRAN, networking, regional commitment. At least here in ASEAN, we are lucky to have that in the area of STI, and the STI department of ASEAN has been very supporting for open science. Collaboration, and I mean, for the other regions, UNESCO is there to help all different stakeholders and countries. We do have a network of STI policy, STEPAN, with 21 members from this region. Please get engaged. While you answer, I can inform you, and we will share with you the invitation for, or maybe my colleagues can already share it in the chat, for a session that we are having on AI governance through STEPAN that can be relevant for some of you, and we will have throughout the year more knowledge sharing sessions in that network. Okay, so with this, thank you so much. We collect this, and this is not just to ask you. We really hope to advance our next activities based on your needs and your suggestions. We can't do everything, but this is the way for us to better understand what are the priorities, not only in this session. In every session, we ask similar questions, and this will be for sure reflected in the capacity building course that we will develop after these webinars, and also in different activities that we do. With this, I would like to invite my colleague, from Beijing office. As I mentioned, I has been actually leading the consultations for development of the UNESCO recommendation in this region from around 2020, 2019. She has been involved in many discussions with different stakeholders, and they have done some preliminary mapping of the existing infrastructures. So I would like to ask you, please, to tell us, drawing from your experience at UNESCO and across the region, what are some of the needs and opportunities to strengthen collaboration on open science infrastructure? And I would like to also, after your talk, to have some reflection if our audience thinks that this is something that can be expanded to the region. Thanks. The floor is yours.
Thank you very much, Veerachai. And I'm sorry for Professor Chai, you will be listening to this one for several times already. Yes, so thank you for this opportunity. And I want to acknowledge first Dr. Jinxia Huang and Dr. Yuman Ma from the Chinese Academy of Science, because they conducted this preliminary survey and analysis and mapping in our region. So yes, oops. Is it changing? Yes. Yes, I just wanted to say that, so I'm based in Beijing now, and we are the regional office for East Asia. So we cover the two Koreas, Japan, China, and Mongolia. And so that was then the focus of our mapping. And then, yes, I will give you a bit of background, survey results, what was the survey about, the results, and some conclusion and recommendation, and a brief introduction to OS10 and this alliance that the Chinese Academy of Science is promoting. And it's one of the decades project and recognized by UNESCO. So first of all, and a few of you actually have been in that discussion from 2021 or 2022 even, on then what we could do as a region for this implementation of this UNESCO recommendation. And so at that time we were already talking about open science infrastructure, and one of the discussion with SOI-Asia was to have a mapping of what were to be then interoperable, so that we could then move to interoperability of all these open science infrastructure. So when I moved to East Asia, so the topic was still very relevant. So that's what we have been then working on. And then also from the Jakarta time, the regional time, we had discussions on what would be, if we need it, or what is then a kind of regional open science platform for our region. So I don't come back to the definition of what we looked at as open science infrastructure, but the aim of this survey was to get an overview of the existing open science infrastructure in East Asia in particular, and then identify the opportunities of what could be shared, and also understand the regional interpretation implementation of interoperability. And then we had also a little part on the metadata in non-English languages, but for that part, we don't really have a very result. So the really three objectives of this survey was to understand the landscape on open science infrastructure, to understand the interoperability in our region, and then that metadata in non-English languages as well, and then the links with interoperability. So we have been conducted last year since May, this in collaboration with the Chinese Academy of Science. And they have put, we have together an expert team with then the members, representative from then the 5 countries that we cover in Beijing. And so that's the working framework. So first there was a desktop review on what was the landscape of global open science infrastructures. And the second part on selecting what would be then the open science infrastructures that would be considered within then this survey. And then the development of the survey itself. And we have circulated it, I think, in several of the groups that are present here. And it was then distributed to then through then our experts to some targeted institutes. So for the selection then of the high quality open science infrastructure, they needed to be national level, accessible and inclusive, having interoperability and standard compliance, having a governance and sustainability, and also like international a part on internationalization and disciplinary diversity. So then they were kind of identified. And yes, so just let me come back to first on the landscape of global open science infrastructure. And we have exactly the same things as what Professor Chai also showed into then network and development things as well. So the challenges usually are on the fundings, on the governance, also on lack of synergies, and the framework, and as well as for interoperability, lack of mature cross-border collaboration mechanism in practical cases that we could see. And the difference in data privacy regulation across the region. So then we have compliance risk and the lack of mature semantic alignment tools for multilingual mapping. So then back to the results of our survey and our respondents. So we had 74 responses, so a lot from China. And then so the results here, so mainly they were all universities, research institutes, and I think they were, and for the research institutes, they were all governmental. So we had four kind of parts as well for like a general understanding. And so the income sources for this open science infrastructure in our sub-region were mostly government grants or research fundings. The languages that were supported were mostly the national one and English. And then the main economic sustainability challenges were unstable fundings and the financial pressure to keep then everything up to date and upgrades and software, hardware, and so on. And also that the open science infrastructure so far are focusing on the later stage of the research cycles, so preservation and publishing, rather than the development and then the conceptualization parts of it. And so on interoperability, so we looked at the 4 parts. So we showed our preliminary survey and so on, and APAN was really instrumental for us to mature then our survey. So we received a lot of comments on what and how we should be focusing or handling that part. So on legal interoperability practices, we found that nearly 80% of the open science infrastructure comply with open standard or protocols. And the challenges were that there was, for cross-border data sharing, was the lack of common data standard and the lack of secure and compliant cross-border platforms. For technical interoperability, we could see that open source were widely used among all, and especially in Japan. And then that the technical obstacles were still the diverse data and metadata format and security and compliance risk issues. And in terms of organizational interoperability practices, we could see that the coordination for the domestic organizational coordination, there are some domestic governance structures mostly, but not necessarily everywhere. And then that for cross-border organizational coordination, we really have to establish a governance structure and policy to help that, to support that. And the difficulty then in that cross-organizational policy coordination were the difference in the national legal systems and policies in place, and also very unclear responsibilities and rights for that. And in terms of semantic interoperability practices for the metadata annotation techniques, so we could see that it was mostly preset rules and templates that were used. And the challenges in multilingual metadata management were still the diversity of linguistic and script, and the limited cross-lingual mapping tools, and also the high cost for maintenance. So now conclusions in terms of this survey was that for the landscape assessment, there is a heavy reliance on public fundings in East Asia for open science infrastructure. The resource type are still like data, journal paper, and so and software, reports, codes, and so on. But they intervene more like at end of the research life cycle. Then on the language support, they were rarely other than the East Asian, the national one plus English, and so, but not other languages. And then the targets for this open science infrastructure are researchers and governments, and publishers and funders and librarians play more supportive roles. So the coverage are usually global, and more than 30% of them the infrastructure were covering more than 100 countries. And then yes, this I already said. So the research lifecycle services, we need to support more like earlier stages of for the support of open science infrastructure for earlier stages, such as knowledge creations and research evaluation and so on. So for the interoperability, so on the legal one, most open science infrastructure have recognized that we need standard and legal use of data. The domestic organizational interoperability, we have quite some differences of coordination mechanism. among the different countries. And then that adds then into the difficulty in the cross-border organizational interoperability, because we need to establish a kind of cross-border mechanism. So it's still at very initial stage. And on the technical interoperability, there are differences on the integration integration and the use of open sources among the different countries, and on the semantic interoperability. So the semantic annotation of open science infrastructure metadata is still practical technologies with low technical threshold, and the adoption of FAIR principle are quite high, which we found exceeding 70%. So some preliminary recommendation that we had. So on the interoperability, for the legal one is to establish a unified framework and compliance procedure for the cross-border data sharing, and promote also mutual recognition of data usage terms. For organizational interoperability, we found, yes, we need to develop and share trust and data framework and strengthen also the governance coordination. And well, so it's proposed, but so we need a more like a coordination mechanism and policy governance framework and policy coordination, which needs to be like transnational. In terms of technical interoperability, so to continue promoting open sources codes, to adopt unified data and metadata standards, and to build regional technical support tools, open them to our members. And on the semantic interoperability, to develop a regional corpus of scientific resources and multilingual domain ontology. So that we support automated semantic annotation of data, and to develop as well multilingual metadata standards and intelligent cross-lingual mapping tools. Maybe that's almost happening. Well, technically that might be now becoming very possible. And in terms of the strategic recommendation as a whole, so we have 4 categories on co-building infrastructure network and implementing then open principles and unifying standards on the infrastructures, and to share then infrastructures and to monitor and enhance mutual trust and infrastructure. So they are more like detailed recommendation. But then in that spirit, the Chinese Academy of Science has proposed this initiative. So these are the slides that I'm sharing with their permission, what they call OS10. And so it's an initiative towards open science infrastructure sharing network, so based in China. And so they would like to create this global alliance in open science infrastructure to deal with issues like fragmentation of infrastructure, unequal participations globally, and then the lack of coordination and the growing policy momentum, and then to kind of coordinate that. So their vision is completely aligned with then the UNESCO recommendation on open science, but as well as the Decade of Science for Sustainable Development. And they would like to support globally, global and local knowledge and data sharing to ensure then equitable access and empower everyone with the right to participate and benefit from scientific infrastructure. So they will bring together global stakeholders to co-develop then open science infrastructure and sharing on the network, explore then the feasible framework and sharing strategies across regional and cross-disciplinary, and to facilitate a global sharing, to facilitate then the consensus making on based on priority areas and practical implementation pathways. I have more, but I think that will be. I will, yeah. now it's the stage where they are calling for members to join, and yeah, I should have put some link. I will send it later. If you are interested to participate in this global alliance, more than welcome. And it's not just for East Asia, so that's a global one. And then yes, so that's will be it from me. I hope I didn't take too much time. Thank you.
Thank you so much, Ai. It was very informative. And please, everyone, if you have any interest in either, doing the similar monitoring and mapping in your country, or be a part of a bigger one that we can put together either with ASEAN or STEPAN, please let us know. We can expand this not very soon, but we can work on it in the next months. And also, yeah, so also for the initiative from China, feel free to send us emails. I just want to share this last slide before we close to, first of all, invite you to our next session 1 month from now on 26th of March on open data, which is also very relevant to those interested in open infrastructures, especially the digital ones. The same time, most probably. Please, your questions, your comments, if you think you can contribute in some of these sessions and discussions, please send us an email to pcv.jakarta@UNESCO. Also, questions for you can share with us. Please let us know what you need to know more about open science and which areas, who wants to contribute. And soon we will send a survey after our 5th session for a bit of evaluation of how useful these webinars are for you. Thank you so much. Thank you all our distinguished speakers. It was very lovely to listen to your experience and expertise and sharing these diverse infrastructures. Hopefully those who needed this information to develop or get engaged more, they received it. We are here to connect you to any of the speakers if needed. So with this, I would like to close. I apologize that we didn't manage to have enough time for discussion today. Next time we had a lot of good speakers. We couldn't, we couldn't deprive ourselves from any of them. So we went a bit longer today. Thank you. See you next month. Bye.
Bye. Thank you, everyone.
Thank you, everyone.
Thank you. Bye-bye.